Good morning, everyone. Happy Monday. A couple weeks ago, we reviewed factoring. And today, what we're going to be doing is reviewing multiplying and dividing rational expressions. So, the steps when we multiply and divide is the very first thing we always look for is we factor. We see if we can break down any part of our fraction using a GCF, the big X, difference of squares if you see a perfect square, or grouping if it's a big polynomial of 4 or more terms. So we're going to take a look at a few examples of multiplying and then a few examples of dividing, and then you guys will be set. So very first thing in number 1, we have 3x over 5x minus 15 times x minus 3 divided by 9x squared. Alright, so we have a fraction times a fraction. This is a rational times a rational. First thing we look for is factoring. 3x cannot be broken down, so I leave it the way it is. So I'll put 3x. Alright, now this 5x minus 15 that's underneath it, that can be factored. Are we going to be using GCF, big X, or difference of squares? I'll just tell you up front on the examples that we're going to look at today, we're not going to be using grouping as factoring. So both 5x and 15, we can't use the big X there because there's no squared. Same thing with difference of squares, there's no perfect square there, so we're going to use a GCF, and the number that goes into both of those is a 5. Alright, 5 goes into 5x once, so we're going to be left over with just an x. Alright, so basically what we're doing, let me get a pencil because this is a little smaller. Where'd my pencil go? All my markers are rolling away. Okay, there we go. Got my pencil. We are dividing both of our terms by the GCF that they have in common. So we're dividing both of those by 5 and putting our GCF outside. Alright, so 5x divided by 5 is x, and then negative 15, that minus 15 divided by 5 gives us a minus 3. Alright, so we've factored our first term. Now we're going to put that multiply sign, and we're going to show what our second term is. X minus 3, can that be broken down? Nope, there's no GCF, we can't big X it, so x minus 3, and then 9x squared. That also cannot be broken down, it's just one single term. So we've got 9x squared. Now what we do is we look to see if anything can cancel out, meaning that we have something on top that is identical to something on the bottom. Or maybe the factors can be identical. So like for example, this 3 and this 9 are not identical, but 3 and 9 have a GCF of 3. 3 can go into 3 once, and 3 can go into 9 3 times. So we can break that down by canceling out common factors. Alright? Then we have an x minus 3 on top and an x minus 3 on bottom. So I can completely cancel out that whole term right there, because we had one on top and one on bottom that were identical. Alright? We also have an x on top and an x squared on bottom. Alright, so I have one x on top and I have 2 on the bottom. If I cancel out one of these x's, I'm going to be left with 1x. So I could put a 1 here in the exponent, or I could leave it as just x. So now we are going to rewrite the remaining factors. So we've canceled out everything that looks like we can cancel out. The only thing that is left on the top is this 1. Alright, so I'm going to put 1 on the top of my answer, the top of my fraction, and on the bottom I have 5 times 3 and this x. Alright, so then to write our final answer, we just multiply those denominators together, so we're going to get 1 over 15x. And there's our final answer for multiplying those rationals. Let's take a look at a couple more examples and then some dividing. Alright, here with number 2, see how much space I got on this paper. Ooh, lots of space. Alright, so again, first step, always factor. Factor whatever you can. So this x plus 5, can't factor that. So I'm going to leave it as x plus 5. Maybe draw a line here. Okay. On the bottom, we have x squared minus 4x plus 3. Can we factor that? Yeah, we can. We can use what method? The big X. Alright, so we're going to big X this. So on the top of our big X is going to be the 3, because we have A times C, so 1 times 3 is 3, and then B goes on the bottom, which is a negative 4. Alright, so what multiplies to 3 and adds to a negative 4? That's going to be a negative 1 and a negative 3. Negative 1 times negative 3 is positive, and when you add them together, you're going to get a negative 4. So in the bottom of our fraction, we're going to have x minus 1 as one of our factors, and x minus 3 as the other. Alright, put our multiply sign, and then here, x minus 3, we had that before. We can't factor that, so we're going to leave it as x minus 3. And then our bottom here, we have 4x plus 20. This cannot be big X'd. We don't have any perfect squares, but we do have a GCF. Both of these can be divided by 4. Alright, so I'm going to put a 4 on the outside of my parentheses. 4x divided by 4 is just 1x, and then 20 divided by 4 is 5. Alright, so now what we're doing is we are looking what we can cancel out the common factors that are one on top and one on bottom. So we've got an x plus 5 on top, x plus 5 on bottom. We have an x minus 3 on bottom, x minus 3 on top. And that looks like that's all that we can cancel out. So now when we multiply straight across, do we have anything on top of our fractions? No, nothing. So what do we put on top of our fraction here? 1. Alright. And then here we've got just an x minus 1 and a 4. So I'm going to put that 4 in front since it was already in front outside of parentheses. Sorry, I was about to burp. And then our x minus 1 can go right here, and we can just leave our answer as that. Cool? Alright, one more example of multiplying rationals. We're going to take a look over here at number 3. There we go. So, got a little bit more going on here. We've got this 3x minus 3x squared. Alright, so we do have an x squared, but we've got a lot of stuff in common here. So let's take a look at GCF. They both have a 3 in common, and they both have an x in common. Alright, so if I take a 3x out of both of them, so basically what we're doing is here we have a GCF of 3x. So 3x divided by 3x is just going to be the number 1. Alright? 3x divided by 3x is 1. What about, then we've got a minus sign, 3x squared divided by 3x. We're going to be left over with 1x because this has a 3x squared. X squared divided by x will leave you with an x. Alright, if we were to multiply that back out, we would get this numerator. Alright, then for our bottom, for that denominator there, we can factor that using the big X. Alright, so A times C would be -5, goes on top. B goes on the bottom. So what two numbers multiply to -5 and add to a +4? We should get 5 and -1. So underneath here we're going to have x plus 5 and x minus 1. Multiply sign, the rest of our fraction. Alright, here we've got x squared plus x minus 20. Let's big X that. Alright, what's going to go on top? The -20. What's going to go on bottom? This is just x. So how many x's is that? 1. 1x. Alright, what multiplies to -20 and adds to +1? Alright, this should be a +5 and a -4. So we're going to have x plus 5, x minus 4. And then on the bottom, 3x can't be factored. Alright, so now let's start canceling stuff out. Let's see here. We've got a 3x on top and a 3x on the bottom. We've got an x plus 5 on the bottom and an x plus 5 on the top. Anything else we can cancel out here? These have the same, like, terms in them, 1 and x and the minus sign, but are they the same? Because here on the bottom, this is a -1. It's x minus 1. But up here, what kind of 1 is that? Is it positive or negative? There's no sign in front, so that's saying this is a positive 1. So these terms are not identical, meaning we can't cancel them out. So our final answer here is going to be, we're just going to leave it in this factored form, 1 minus x, x minus 4 in our numerator, and then down below we have x minus 1. And that's it. Alright, so there's multiplying rationals, a quick review of that. I'm going to move my paper and we're going to review dividing rationals, which is very, very similar, guys. Alright? So remember that when we divide rationals, what we're doing is we're multiplying by the reciprocal. Alright? So in other words, this is also where we keep, change, flip. Alright? We keep our first fraction, we change the division sign to a multiplication sign, and then we flip our second fraction. Alright? So what we're going to do is take a look at these examples down here. I'll show the steps there so we can see them. And then you guys will be set. Alright, so remember, step 1 is multiply by the reciprocal. Okay, so we are going to keep this 7x squared over 3x squared minus 27. Keep. Then we're going to change that division to a multiply sign, and we're going to flip our second fraction. So 3x minus 9 is going to go on top, and 4x squared is going to go on bottom. Alright, keep, change, flip. Second step, now this is just like the multiplication we were doing before. All right? So we're going to factor and then cancel out what we can. Okay, so this 7x squared cannot be factored, so I'm going to leave it as 7x squared. Here in our denominator, we have 3x squared minus 27. So what we're going to do here is we're going to factor out a GCF. I'm going to factor out a GCF. And when we do that, they both have a 3 in common. So we're going to get 3. Yeah, I'll just do it here. Sorry, this one has a little bit more to it. So we have 3, and then 3x squared divided by 3 is going to leave us with x squared. 27 divided by 3 is 9, so minus 9. What you guys might notice about this is we still have an x squared, and there's something else tied to it. So we could use here, this is the difference of squares. You can big X it if you want to try that, because you should still get the same thing. But the difference of squares, x squared is a perfect square, and 9 is a perfect square, right? So this is diff of squares, because we have x squared and 9 are both perfect squares. So we can rewrite this 7x squared over 3. Now, what's the square root of 9? 3. Okay, so what we're doing is we're going to break this down and split it into multiple factors. So this is going to become x plus 3 and x minus 3. Alright, you could do the same thing if you big X'd it. If you big X'd that, that means negative 9 would go on top, and there's no x in the middle. It's either x squared or no x at all. So 0 would go on the bottom. The two numbers that multiply to negative 9 and add to 0 would be 3 and negative 3. So that's how we got these factors down here. Alright? So there's our first fraction. Took a little bit more work, but we got there. Alright, and then for our second fraction, we have this 3x minus 9. Is there anything we can do there? Yeah, these both have a GCF of 3. 3 can go into both 3x and 9. So I'm going to put a 3 on the outside. 3x divided by 3 is just going to be 1x. And then 9 divided by 3 is 3. Then on the bottom we have 4x squared, which cannot be factored. And now we cancel stuff out. Alright, so I have an x squared and an x squared. I can cancel those out because there's no plus or minus sign right next to them. Alright, they're multiplying by the 7 and 4, and so it's okay if I divide them out. Alright, but you cannot cancel them out if they're not identical and they have plus minus signs next to them. We have an x minus 3 and an x minus 3. We have a 3 and a 3, and it doesn't look like anything else can cancel out. So our final answer here is going to be, the only thing on top is this 7, and what's left on bottom is a 4 and that x plus 3. So I'll put 4 parentheses x plus 3. Alright, so if you guys can multiply rational expressions, you can easily divide rational expressions just by changing it to multiplication and flipping your second fraction, and then multiplying like you guys know how to do. Alright, if you have any questions, don't hesitate to reach out to me and ask. See you guys next time.